All right, let's take down another Mtel question. This one says points A, B, and C are plotted on a coordinate grid to form angle ABC. If angle ABC is a right angle, which of the following relationships must be true? And we've got all these answers. Let's take a look at what's going on in these answers. So we've got A minus B in answer A. So A minus B, those are the y values of these 2 points, over 2 minus 5, which are the x values of these points. So that's the change in the y over the change in the x. So that looks a lot like a slope calculation to me, which is interesting because we're saying that this angle is a right angle. So we're saying that the 2 lines are perpendicular at a point. And we know there's a relationship between perpendicular lines, that the slopes are negative reciprocals of each other. So we're going to be looking for the answer where one slope calculation is going to be the negative reciprocal of the other one. It's odd that the answers are set equal to each other, because if we were to calculate the slope for both of these situations, they shouldn't be equal. They should be negative reciprocals. So one of these slope calculations must be manipulated in a way that it results in it being the negative reciprocal. So something's going to have to be flipped around in one of these answers, which is going to be odd to look at. So let's take a look at A. So the left side of the equation is A minus B, which is the change in y, over 2 minus 5. So this right here is a normal slope calculation. Slope is typically m equals y1 minus y2 over x1 minus x2, right? And that's exactly what's happening here. We have our first point A and our second point B, and we've got our first y value minus our second y value over our first x value minus our second x value. The right side of the equation has 5 minus 9, which is the first x value of one point minus the second x value of the second point, and that over c minus b, which is the second y value minus the first y value. So there's definitely some switching happening here. Let's take a look at what happened. So if we consider the reciprocal of our slope formula here, right? So I'm gonna call this mr. The reciprocal is just flipping the fraction upside down. So we're gonna have x's on top, y's on the bottom. So x1 minus x2 over y1 minus y2. So it kind of looks like that's what's happened here, right? Instead of having our y's over our x's on the right side of the equation, we have our x's over our y's. We have 5 minus 9 over c minus b. Well, the c minus b thing is kind of reversed. Instead of having y1 minus y2, we have y2 minus y1. Well, with perpendicular slopes, we want the slopes to be the negative reciprocal of each other. So let's introduce a negative into the bottom of this fraction to make our negative reciprocal of our m equation. So I'm going to keep the top the same because it looks like the top in A stays exactly the same. So it would be x1 minus x2. And then I'm going to introduce a negative into the bottom of this. So I'm making the whole thing negative by just making the bottom of this negative. If you put a negative into a fraction, you can put it in the top, put it in the bottom. That makes the whole thing negative. And we want this to be the negative reciprocal. So I'm going to put this in here as a negative. We add y1 minus y2. Well, if I multiply this negative through, it's going to change both of the signs on both things. So what we actually end up with is y2 minus y1, which is exactly what's happening on this side of the equation. So what they've done in A is created our negative reciprocal equation on the right side of the equation and set that equal to the normal slope. So that means that these two sides of the equations have to be reciprocals of each other. So our answer is A.